So now let's get started with a different section of 3D geometry. We need to find shortest distance between two non-intersecting lines. What are such non-intersecting lines called? These are known as skew lines. If they are non-parallel as well. That is, two skew lines are neither parallel to each other nor intersect each other. So skew lines can be possible only in 3D because in 2D, if the line is not parallel to another line, then they must intersect. So in 3D, skew lines are possible, and the straight line which is perpendicular to each of the non-intersecting lines is called line of shortest distance. So obviously, the straight line which would be normal to both the lines would be the shortest distance, would be along the shortest distance. In the given diagram, we have this line and this L1 and L2. Here, clearly it can be seen that that normal to the first line, which is normal to second line as well, only gives the shortest distance. It can also be proved mathematically. Now, let the equation of two non-intersecting lines be x minus x1 by L1 equal to y minus y1 by M1 equal to z minus z1 by N1, which is R1, say. And similarly for L2. So, shortest distance between these two are given by the formula AB is mod of, that is determinant of x1 minus x2, y1 minus y2, z1 minus z2, L1 m1 n1, L2 m2 n2. So there's a trick to remember this formula, that in the determinant all the rows are all the rows are some of the other direction ratios. That is, if say this is L1, say this is L2. So L2 must have a point x2, y2, z2 on it, and L1 has a point x1, y1, z1 on it. So this is a direction ratio. The direction ratios of these two, then L1 m1 m1 and L2 m2 n2. So the shortest distance is like this. It can be solved, but the process is quite tedious. So let's move on. So now we would be starting with an entirely different topic, the planes. Till now we were studying only the lines, and now we would be starting with the planes. What are planes? Planes are basically a collection of points which are equidistant from a given point. This is a given point. So all the collection of points which are equidistant from here, all these points lie in the plane. They actually need not be equidistant. Plane is basically a surface. A horizontal surface or a vertical surface, or say any inclined surface. Plane is a surface. So planes are represented in 3D, and the general equation of a plane is ax plus by plus cz plus d is 0. Now, there are equation of planes in various forms, and we'll take a quick glance over it. In normal form, normal मतलब कि परपेंडिकुलर होता है जो, अब प्लेन का इक्वेशन हमें परपेंडिकुलर उसके प्लेन का इक्वेशन हमें प्लेन के परपेंडिकुलर के टर्म्स में चाहिए. तो द इक्वेशन इज Lx plus My plus Nz equal to P, where L, M, N are direction cosines of perpendicular to the plane, and P P is the length of normal from origin to the plane. So we'll see how this happens. Like, this is the plane, this is the origin. So from origin we drop a perpendicular and its length is P. Now for the plane, normal vector is Li plus Mj plus Nk, that is direction cosines of this line are L, M, N. So the equation of plane in this form is Lx plus My plus Nz equal to P. This is called the normal form. Now moving on to the next form, we have equation of plane passing through a point and having direction ratios A, B and C for its normal. So instead of in the previous case we had direction cosines, here we have direction ratios. So as direction cosines are nothing but proportional numbers to direction ratios, it would hardly make any difference. Now see, general equation of a plane is that Ax plus By plus Cz plus D equal to 0. x1, y1, z1 lies on it, implies ax1 plus by1 plus cz1 minus of this equal to D. Now we would have the equation of plane. Putting this here, we will get ax plus by plus cz plus minus ax1 minus by1 minus cz1 equal to 0. This would give this equation. Hence we can find out the equation of plane passing through a point and with direction ratios of its normal given. Now the equation of plane through three non-collinear points x1, y1, z1, x2, y2, z2 and x3, y3, z3. Three non-collinear points. What does it mean? What are non-collinear points? It basically means that they cannot be located on a single line. That is, A and B are collinear points. These 3 points are said to be collinear, but if C is here, then they are non-collinear. Now, through 3 non-collinear points, this is my plane. Here point A, here point B, here point C. So we need to find the equation of plane, and there is only unique plane passing through these 3 points. The equation is given by this formula, which is determinant of x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, and x3 minus x1, y3 minus y1, and z3 minus z1, which is equal to 0. Now we'll find the equation of plane in intercept form. What are intercepts? Intercepts are the cuts made by the plane along x, y and z axis respectively. So that plane whose x-intercept, y-intercept and z-intercepts are A, B and C respectively, the equation of that plane is x by A plus y by B plus z by C is 1. Here we need to draw the figure. Let's say these are our axes, x, y and z. So A intercept would be like this, B intercept would be like this, like point B is here, and C intercept would be like this. So these are the cuttings of a plane. This is the plane required. Okay, so now moving on, we now find the angle between two planes. So the formula for angle between two planes is cos inverse a1 a2 plus b1 b2 plus c1 c2 by root of summation a1 square into summation a2 square. So this is clearly same as the formula for the angle between two lines with direction ratios a1 a2 b1 a1 b1 c1 and a2 b2 c2. So how does these two come out to be same? So let's find out the reason. It is because this is my plane. P1, P2 is say like this. This is P2. This is my theta. Okay. So if planes P1 and P2 make angle theta, then the normals of the plane also make angle theta. Now, as normals have direction ratios A1 B1 C1 and A2 B2 C2, the angle between the normals and hence the planes is given as this. Now we'll see various conditions in which summation A1 A2 becomes 0 or A1 by A2 equal to P1 by P2 equal to C1 by C2. Now if summation A1 A2 becomes 0, then planes are perpendicular to each other, because cos inverse 0 is pi by 2, implies theta would be pi by 2, hence the planes are orthogonal. Now if A1 by A2 equal to B1 by B2 equal to C1 by C2, then planes are parallel to each other, because both the direction cosines are parallel to each other. So now we move on to family of planes. This is a very important chapter, very important topic as far as JEE syllabus is concerned. There's definitely a question on this. Now family of planes. Equation of planes. Let's say we have two planes intersecting in the same line, and we need to draw infinitely many planes passing through that same line. So actually the initial two planes define a family, and hence we can then find an infinitely many passing through the same line. So let's say this is P1 and this is P2. Okay, so this is the common line of intersection L. Now the plane 1 is u equal to 0 and plane 2 is v equal to 0. So equation of all the planes passing through this line of intersection of planes P1 and P2 is family of planes of the plane P1 and P2, and is given by u plus lambda v is 0. Now moving on, we'll see we'll now see the intersection of a line and a plane now, and as well as the angle between them. So here we have a plane and also a line which intersects the plane. So angle between plane and straight line. Angle between the plane and the straight line is actually 90 degrees. See, angle between the plane and the straight line is this theta. Now n is normal to the plane. So angle between normal to the plane and the line is pi by 2 minus theta. So cos pi by 2 minus theta is al plus bm plus cn by root a square plus b square plus c square, which is same as sin theta. This is the expression for angle between a line and a plane who are intersecting each other. Now let's get moving. Okay, in this slide we'll now learn about bisectors of planes, as well as how to derive equations of them and remember them. We'll now focus on the bisectors. So we have two planes given. Let's say this is P1 and this is P2. So equation of planes bisecting these two planes would be, one would be this one and another would be this one, and one is this one. That means this and this. So we would have two possibilities, that is bisecting either the obtuse angle between the two planes or bisecting the acute angle. So if the equation of the two given planes is a1x plus b1y plus c1z plus d1 equal to 0 and a2x plus b2y plus c2z plus d2 equal to 0, then we need to remember that equation of bisector of the planes would be given by a1x plus b1y plus c1z plus d1 by root of summation a1 square equal to plus minus a2x plus b2y plus c2z plus d2 equal upon root of summation a2 square. So now moving on, we'll see next we have perpendicular distance of a point from a plane. So how do we find it? Let's say this is a plane and this is a point. We drop a perpendicular from that point on the plane. Now we need to find its length. This is plane and this is perpendicular to the plane. Okay. Let's say Q is the foot of perpendicular from point P. So point P is x1, y1, z1, and the plane's equation is given as ax plus by plus cz plus d equal to 0. So perpendicular distance L would be ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square. This is actually obtained as a consequence of distance formula. So P would be this you need to remember that P is ax1 plus by1 plus cz1 plus d by root of a square plus b square plus c square, which is always the length of foot of perpendicular from a point to the plane. So now we move on to the last topic of 3D geometry, that is sphere. Sphere is described in JEE syllabus as well as it needs to be incorporated in daily life. Like we can apply various 3D level problems on Earth, assuming Earth to be a perfect sphere. Like let's say we need to find this is Mumbai, this is Delhi, this is Kolkata. So let's say we need to find distance between Mumbai and Delhi exactly. So as Earth is curved, let's say Mumbai is here, Delhi is here. This is radius, this is center, and this is radius. Okay, so by knowing the coordinates of point D, M with respect to a 3D coordinate system fixed with origin as center of Earth. So we'll then find coordinates of M and D and then locate it on r, like the distance would then become r theta. That is, we need to find theta. That is our goal. So sphere. How is a sphere defined? Sphere is defined as let's say a sphere is defined as locus of all the points which are equidistant from a fixed point. Now there's a term in spherical systems, that is geodesic. What is geodesic? The shortest possible distance between any two points on a sphere is termed as geodesic. So let's say this is a sphere, shortest possible distance between any 2 points. That is, shortest possible distance is always the line directly joining the 2 points. So geodesic is shortest possible distance between 2 points. Now we have great circle. Now what is great circle? the circle which is formed as a result of intersection of the surface of sphere with the plane that passes through the center of sphere. That is, surface of the sphere. This is a sphere. Let's say we have a plane like this, and it is passing through center of this sphere. So this plane would cut out a circle, a perfect circle with radius as the radius of the sphere itself. So great circle would be the largest circle possible to cut out through a plane. So there can be infinitely many great circles, because they can be like any orientation of the planes which we are like, from which we are cutting the sphere. Now, equation of sphere in diverse forms. So first form is, we'll first write the general equation of sphere and then move on to specific equations. Now, equation of a sphere with center a, b, c and radius r is given by x minus a whole square plus y minus b whole square plus z minus c whole square equal to r square. Or this can be simplified to x square plus y square plus z square plus 2ux plus 2vy plus 2wz plus d equal to 0. So this simplification, this equation has center as minus u minus v minus w, and radius is given by root of mu square plus v square plus w square minus d. Now, which is these two formulas are quite similar to the circle formulae, as center of the circle is equation of the circle is x square plus y square plus 2gx plus 2fy plus c equal to 0. Center used to be minus g comma minus f, and radius equal to root of g square plus f square minus c. So everything seems to be quite related, and as there's quite analogy between sphere and circle, so we might expect this to happen, like the formulae coincidence. So diameter form, another form of equation of a sphere was is the diameter form. Here extremities of a diameter are given, and then we need to find equation of the sphere. Let us say this is our sphere. No, it actually appears as oval, it is not a sphere. Let us say this is our sphere. Extremities of diameter are given. This is A and this is B. These two extremities are given. So equation of sphere would then be x minus x1 into x minus x2 plus y minus y1 into y minus y2 plus z minus z1 into z minus z2 equal to 0, which is very similar to the diametric form of circle, which used to be x minus x1 x minus x2 plus y minus y1 y minus y2 equal to 0. So this finishes our topic 3D geometry, and this is Jaikumar Balani signing off.